girls' maths literacy class.
Why not if there are little people in that group?
So group 4 was, I think, 15 and 17. So 15 in my class, 17 in the Sis Dustin's class. And some of them are comorbidities, so they combine them. So that's a total, I mean. So it would obviously be half that.
Oh.
Okay, so we need to do trigonometry. So I want a nice trigonometry heading just so that it's clear to you that we are officially starting trigonometry. Okay, we are 10.5. We are group 2. Today is Monday, and it is the 31st of August. Okay. Just so weird. So we generally just refer to trig as trig. You're welcome to write out the whole word if you want to. So trig comes from the fact that we have a special relationship between the sides and angles in a right-angled triangle. What else do you remember that dealt with right-angled triangles? It was also in your investigation. Pythagoras. Pythagoras also dealt with right-angled triangles. But that was specifically that the two shorter side squared is equal to the longest side squared. So we mustn't forget that, because Pythagoras is sometimes still the easier way to do things. But what trig allows us to do, which Pythagoras does not, is to relate the angles and triangles, angles and lengths in the same sum. Okay, I'm just trying to find the notes from, there we go. So that's the first thing. It is based on a right-angled triangle. And now, unlike Pythagoras, we have a relationship between the angles and the lengths of sides. So Pythagoras was just sides, but trigonometry, we can do angles and sides in the same calculation. So just note there that Pythagoras was a relationship between sides only, and if we had two sides, we used Pythagoras to calculate the third side. In trigonometry, we need two bits of information to calculate a third bit of information. So we need two sides to get an angle, or an angle and a side to get another side.
So next time we're doing this and we're doing twos. What are we doing?
I don't know yet. We're still waiting for the Department of Education to specify what we have to do by the end of the year and what has to be examined by the end of the year.
Last thing for the whole entire year.
Not that I'm aware of.
So
So this would have been the last content, but we are obviously going to try and go back for some things from lockdown.
Okay, so that's
But this is the last thing that you haven't touched. Yes. Can everyone see you on the board? Matthew and Keegan? Can you see it fine? Okay. Henry? Okay. So a triangle, we know, and it seems like a stupid statement to make, has three sides, right? But now these three sides, we call different things as my reference angle changes. Okay? Has three sides, we call it the hypotenuse, the adjacent side, and the opposite side. And very important that when I have the same triangle, but I change the angle that I'm working from, my opposite and adjacent also have to change. But the hypotenuse will always be the hypotenuse. My hypotenuse is always opposite the 90 degree. Always. Doesn't matter the triangle. The adjacent is the side touching my reference angle. And my opposite side is the one opposite my reference angle. And you will understand in a moment what I mean by reference angle. Once you have that, you're going to draw quite a large, I would say about half a page triangle, because we're going to write quite a bit of information. Or a third of a page is fine.
Then that's an angle, symbolize.
Yes, an angle. Lost my ruler, it's really annoying. No, I have, thanks. I have like 500 of them. I just don't have another 30 centimeters here. See? I have 3 in there. I just wanted that one. So while you're still waiting, you can draw a right angle triangle about a third of your page at the smallest, please. So just a standard right angle triangle. This is just quickly showing you. This is the one that I've drawn. Just for those that are still busy writing notes so that they can still finish their notes. Yeah. Anyone so busy with the notes? Or we're all drawing triangles now? Okay, there, triangle. Just like that. Right angle triangle. Then I want you to have 2 additional writing utensils. So either a highlighter, a Koki, a pencil, something that you did not draw your triangle in. So I will use brown and purple, but you can use anything. Maybe a pencil and a red pen, or a pencil and a black pen, or anything else. Okay, so still in the same color that you've drawn your triangle in, where would I find my hypotenuse? No, that's not allowed. Okay, that is called sharing. We aren't allowed to share because contamination can occur. There might be something on that pencil bag. Maybe Courtney's a carrier, maybe Matthew's a carrier. Definitely not a good idea. Okay? So do you literally only have one pen?
One color pen.
So then improvise, make it bolder and thinner. Okay, so in my triangle that I see, doesn't matter what the triangle is, where is my hypotenuse? Opposite in terms of what Keegan said, the diagonal, it's opposite my 90 degrees. So in the same color as your triangle, I can't spell now, hypotenuse. Okay? Now, I am going to put in a reference angle, and it might not be something you've heard before, but in trigonometry, we often talk about theta. Theta is a circular kind of O with a line at its belly. So I'm now calling theta my reference angle. So since I have a reference angle, I need to reference adjacent and opposite according to theta. So theta, adjacent, the line that touches theta. There's theta, there's the line that touches theta, so this is my adjacent side. And therefore the line opposite theta is the opposite side. Different color, please. Theta and the opposite and adjacent in a different color. Then I'm going to do I changed my mind and doing orange on purple. Now I'm going to change my reference angle and I'm going to call it a different angle. And another common one we use is beta. Looks like a capital B with a long tail. A new color. And now once again I have a new angle, which means I need a new adjacent side and a new opposite side. The side that touches the beta is now my adjacent side. And the one opposite beta is now my opposite side. So can you see that even though hypotenuse is always hypotenuse, my adjacent and my opposite will always change depending on where my reference angle is. Now we've called it theta and beta. I can call it A, B, and C if that's what the vertex of the triangle was. So then that would be angle A, that would be angle B. And I can keep to the sides as AC and CB and AB. BETA. And theta is THETA.
If the triangles are plain, one side is like, how would you know which one is
It's still, there's my theta, still touching theta, so it's still the adjacent. There's beta, still touching beta, so beta is adjacent to AC.
But how would you know which one is theta and beta?
They would give it to you, or they would say sine A, sine of A. So then there's A, so there would be that angle that they're referring to. So in my next activity, we're going to go through all the different things that we could call it. Okay, so I'm just introducing you to new things. So here I have now gone, theta is my reference angle, so adjacent touches theta, and opposite is opposite of theta, and that's the brown. And then beta is the angle at A, but the adjacent line is AC, and the opposite line is BC for that angle. So it's always going to depend on where your angle is. So now we're going to look at what I could call those lines. So yes, I know that it is the adjacent side, and yes, I know that it is the opposite side, but we still have to call them by their names. So we can call this one AC, and that one BC, and that one AB, but there's another terminology that I could try and trick you with. So have you noted that I'm using capital letters on all of those vertices, all those points of the triangle? I can try and trick you and use little letters. Now the little letter that I use is the one opposite the capital letter. So if this is capital C, opposite would be little c. If this is capital B, opposite, this would be little b. And if this is capital A, opposite, this would be little a. Now don't confuse little a with adjacent. That's why I've used A, B, and C, because I'm referring to the side length, not the reference. So not opposite adjacent, I'm referring to what I'm calling that side. Little a, little b, and little c. Okay? Now, if I wanted to ask you the different functions, we actually need to know what the different functions are. So let's write them down. Sine, cosine, and tangent. Sine, cosine, and tangent are their full names. We hardly ever use them, but those are their full names. So the sine function, we abbreviate to sine in terms of word, but it is sin in terms of writing. So some people say sin, it just feels weird for me, okay? Cosine, we abbreviate to cos, and tangent, we abbreviate to tan. Sine, cos, and tan. Now, we're always referring to sine of an angle, and cos of an angle, and tan of an angle. So for now, I'm just going to say angle with no reference to anything specific. Now it takes this function sine of that angle and it will be equal to a specific ratio. And that ratio for sine is opposite over hypotenuse. And for cos, the specific ratio that cos angle would be equal to is adjacent over hypotenuse. And for tan angle will be equal to the ratio of opposite over adjacent. So when I talk about the trig ratios, I'm talking about SO, CA, and TOA. Sine is opposite over hypotenuse, cos is adjacent over hypotenuse, and tan is opposite over adjacent. So if you can remember SO, CA, TOA, you will always know which ratio is which. That's Mr. Lawrence who's going to want us to open this door. But we'll see. Okay. So what we're going to do now is we are going to firstly identify the ratio, the opposite over hypotenuse, and then I actually want you to relate it to the side name. Okay. So I'm going to zoom out so we can see all of this in one go. Okay, so I am looking for sine of A. So I'm going to A, and I want sine. Sine is so opposite over hypotenuse. Okay, but now I want opposite to A with little letter A, and hypotenuse, which is little letter C. Sorry, I have to speak. I hate this time of year when it changes from winter to spring. It is the worst. Every morning I wake up and I feel like flubber slipped in my nose. Do you even know what flubber? Isn't flubber a bit before your time? You don't know flubber? Okay. It was a Robin Williams movie. You know Robin Williams? Have you watched the original Jumanji?
Oh, yes.
The old guy with the funny face. He was also the voice of Zazu in Lion King, and he played. Was in a lot of movies when I was a kid. So he made a movie called Flubber. It was like this science experiment that went wrong. It was like this green goo thing that did whatever it wanted. So it would climb the walls and go all messed up. So
you said you feel like that in
yeah, it feels like I have constantly something stuck in my sinuses. Okay, it's very sad. You guys need to watch older movies.
Is it an old movie, man?
Yeah, it's probably before you were born. Or early in your life. I would actually have to Google. So sine, I found sine, which I know is opposite over hypotenuse, but the A is my reference. So there's my A. Even though I've also called it beta, I want you to get used to the fact that I can call it anything. Okay, so there's sine of A. My opposite is BC or little a. Okay, and my adjacent is AC or little, hypotenuse is AB or little c. So there are many ways that I can name these things and ask you to refer to them or understand what I am asking you. So I just want you to be exposed to it from the beginning. So without looking it up, although you have it in front of you, so I don't know why I'm hiding it. Cos is which set of ratios? Car is adjacent over hypotenuse. Okay? You see why naming a triangle ABC can actually be misleading. Because I'm going to cos, which is adjacent over hypotenuse, but I'm going to theta, which just in this case, luckily, my adjacent is called little a. And my hypotenuse is little c. But I can also use the two-letter system if the little letters confuse you. So my adjacent would be BC, and my hypotenuse would be AB. I know I haven't made a mistake. Those two answers are the same, which we will get to later in the week. Okay, so now I'm looking at tan beta, this is tan beta, that is tan B. Okay, tan beta, there's beta, which is TOA, opposite over adjacent. Opposite using the small letters is little a, and adjacent using small letters is little b. Using two capital letters, using the vertices, little a is BC over AC. Can you still see everything? You sure? I can zoom in. Opposite over adjacent. A over B, BC over AC. Okay, tan of B, there's B. Tan I know is TOA. So the opposite side is AC if I'm using 2 letters over BC if I'm using 2 letters. If I'm using the small little letter, it would be B over A. So these are my reference ratios. Those are my actual side names. Sine, we know, is opposite over hypotenuse. So opposite of theta. So there's my reference, is AC over hypotenuse, AB. If I wanted to use the little letters, it would be B over little c. And cos of beta, there's beta. Cos is adjacent over hypotenuse. Adjacent is AC over AB as my hypotenuse. AC's little letter is B, and CB's little letter, no, AB's little letter is C. So there we have practiced everything that I could ask in terms of all the different ways of asking it. And I will integrate them as we work through the week so that you get used to it. Okay. I'm going to draw a new triangle quickly. Anyone still busy? Okay, while you're still busy, let me just draw a new triangle. So I can own, there's another way that I can refer to these things. I'm also going to change my letters so that we can get nicer ones.
So then can you keep this project that you use?
I still want to mark it. I do still want to mark it so that I can see what you understood. So I can see that most learners in the ones that I've already marked did really well, except for about 2 learners. And it's really helped me understand what they are struggling with. And I can foresee what they're going to struggle with as we move along. Okay, finished. Let's look at my next triangle. So I'm still going to call this theta. Okay, I don't need you to write it down. But instead of calling this beta, I want to use theta in that naming. So I know that theta plus 90 plus whatever that is will be 180 degrees. Okay, so I know that 90 degrees, let's write it there, plus theta plus RPQ, or let's just call it angle P, is equal to 180 degrees, and that we know is the interior angles of a triangle. Now, if I want to find a new name for P, what would I do? Fantastic. But can I simplify that further? There we go. So I can also refer to this angle as 90 minus theta. And I will, very often I will refer to it as 90 minus theta. And that is why we call this angle and that angle that's not the 90 degrees co-angles. Because together they will always make up 90 degrees. And that's also why sine and cos are the same in opposite reference angles. So look here. When we did cos of theta and sine of A, there's cos of theta and sine of A. They landed up with exactly the same ratio. And that is why we call them co ratios. So sine of theta will be equal to cos of 90 minus theta. And sine of 90 minus theta will be the same as cos theta. So they are always the same in the opposite reference angle. And that is why we call them co-ratios. But we will work through that little bits. So if I had to say, what is tan of 90 minus theta? I want you to give me the sides that I'm referring to using 2 letters, please. I'm going to ask you to come fetch it here. It's in the second one. You can take as many as you need. Okay, so I want you to know the ratio, and I want you to use 2 letters to name the side.
What is theta?
Theta is just a name of an angle.
So it's no like number or anything.
Not yet.
Okay.
It's just a general angle size.
Then, say the case that they ask us, did you say like the angle of Q, or did you say?
Either one. If theta is on the diagram, you can use theta. If it's not on the diagram, then you can use Q. So I've given you theta, so you know where it is, and therefore I've written it down now, but if I hadn't written it down, you need to know that the other one would be 90 minus theta, or beta, or alpha, or whatever letter I give you. So tan is which ratio? So car. There we go. TOA. So it is opposite over adjacent. Now, what is the side name that is opposite to 90 minus theta? RQ. Remember, I asked for 2 letters. And which side would be adjacent to 90 minus theta? Why not PQ? That's also touching my angle. That's my hypotenuse. Fantastic. My hypotenuse is always my hypotenuse. It never changes. So that is why PQ, even though it's touching the angle and therefore is technically adjacent, is not the adjacent that we are referring to, because that is always my hypotenuse. The adjacent is the other one still touching the angle. What was I supposed to write? PR. Is that why Erin was confused?
Yeah.
Okay, PR. Sorry. There we go. Okay, PRQ over PR. So we don't have that much time. We only have 8 minutes. I'm not going to start anything new. We're just going to practice.
You have 8 minutes of this lesson, yeah?
Mm-hmm.
So you just do
I did go by fast. Okay. I am going to give you some sides. Let's make it interesting sides. No, let's just stick to the standard. Okay, we'll just stick to boring numbers. 3, 4, and 5. 3, 4, and 5. I'm going to ask you to calculate and give me the most simplified ratio of the following. Sine theta, cos theta, tan theta, sine 90 minus theta, cos 90 minus theta, tan 90 minus theta. I also want sine of q, cos of q, and tan of q, and sine of p, cos of p, and tan of p. Let me zoom out quickly. I want the actual numerical ratios, please, not just the opposite adjacent or AC, BC stuff. The actual values.
Maybe you just put new values in.
I just added numbers instead of letters, so I can't zoom out anymore. Let's see if I can do. Okay, there you go. So your top letter is P, R, Q, theta, 90 minus theta, PR is equal to 3, PQ is equal to 5, RQ is equal to 4. So, ka, toa. Giving you only 2 minutes to do all 12.
So can the other exercise would you use this one or just to use the numbers?
So you just have to give me the ratio and the number. Yeah. So the ratio, just so you can get used to it, so opposite of adjacent or whatever, and then the number. Okay, so I think the bell's probably going to catch us. I'm going to leave that for you to finish off at home so you can actually practice before I just give you the answer. You learn nothing when I just give it to you. What I will say is what I did immediately is I wrote all my ratios down. I went opposite of hypotenuse, adjacent of hypotenuse, opposite of adjacent, for all of them. Because no matter where the angle is, sine is always opposite over hypotenuse. Then I saw, okay, well, I know that hypotenuse always stays the same regardless, so I went and put 5s in for all the places that had hypotenuse. And then my next step would be to go to theta, which one's opposite, which one's adjacent, and write down the one that I need. Go to theta, I need the adjacent, write down the one that I need. Theta, go to the one that I need, or the opposite and whatever, okay? And then finish that. Then you will notice that there will be doubles. I've asked you theta, but theta is also q. So these sine theta, cos theta, tan theta should be the same answers as sine q, cos q, tan q. And sine 90 minus theta, cos 90 minus theta, and tan 90 minus theta should be the same as sine p, cos p, tan p. That's why I gave you such little time, but I realized you haven't actually done this, so you are going to need some more time. So please finish that by yourself, not asking your friend, not quickly copying it in the morning. And then we'll quickly mark those values tomorrow. And then we're going to take all of this and start putting it onto a Cartesian plane. Okay.
So sine p would be exactly the same as sine theta.
Yes.
Okay.
I've just named it differently, but it's still the same angles and everything. Okay, let's cut away, please. So like I said, I can give you your mark, but I can't give you your paper. Yes, you can just leave it on the desk, your project on the desk, please. Okay. Good afternoon, grade 10. As soon as you've packed, you can start leaving.